Hi everyone, today in Integrated Math 2 we're going to go over Chapter 13, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Alright, independent and dependent events. A compound event, also known as composite event, consists of two or more simple events. So compound events can be independent or dependent. Events A and B are independent events if the probability that A occurs does not affect the probability that B occurs. So it's not going to affect it even if it's there. Events A and B are dependent events if the probability that A occurs in some way changes the probability that B occurs. Alright, so let's check this one out. So suppose a coin is tossed and the spinner shown here to the right, says green, blue, red, is spun. So the sample space for the experiment is heads blue, heads red, heads green, tails blue, tails red, tails green. Also the possible outcomes that we can have. Then, using the sample space, probability of a compound event to the coin landing on heads and the spinner is on green is the probability of heads and green. Well, there's only one possible outcome for that. So it's 1 out of the 6. And notice the same probability can be found by multiplying the probabilities of each simple event. So you have 1 in 2 chance that it'll be heads, and 1 in 3 chance that it's going to be green. 1 times 1 is 1, 2 times 3 is 6. Probability of two independent events. So if they don't affect each other, just like our previous example with the coin toss and the spinner spun, it doesn't affect it. So we can say the probability of A happening and B also happening is equal to the probability of A times the probability of B, because they're not going to affect each other. So in the case of the previous example, all we did was multiply them. And that's simply what you do here as well. Alright, so let's go over the probability of two dependent events. So if two events A and B are dependent, then we have the probability of A and B, which is equal to the probability of A times, as you can see here, this is how we're going to say it, the probability that event B occurs given that A has already occurred. And this is known as conditional probability. So conditional probabilities, let's say, suppose the dice is rolled, and you already know that the number rolled is odd. So 1, 3, 5. 1, 3, or 5. And we want to know what the probability that the number rolled is 5. There are only 3 odd numbers that can be rolled, like we said. 1, 3, and 5. So the probability that the number rolled is a 5 is, so you have a 1 in 3 chance. And there we go.